Thank you, Franz, for the short introduction. Welcome, everyone, also from our side, to our short dispute today on where the IT enables a revolution or actually simply misses its chances for modern project management. My colleague Josef Gubelmann, I'll actually call him Sefi throughout the talk, if that is okay, because everyone...
It's okay, but I want to call you then Michi. Then.
Michi is okay as well. Sefi and me are responsible for the services all around project management at our company called AWK Group. The company runs projects, mainly IT projects, actually ever since its formation in 1986. In all of these industries, basically all the industries that are present in Switzerland. We are a great place to work, and we're also a great place to grow. We're now a bit more than 400 employees and part of an international consultancy group with entirely more than 800 people. Now, we want to take you on a journey and discuss how IT actually, throughout more or less the life cycle of AWK, IT opened doors to new approaches of project management. And for this, allow us to step back once and have a look at project management history.
Yes, let's start with some ancient projects, almost as ancient as me, of course. Let's start with the Great Chinese Wall. Like every project, this project had a goal. The goal was to protect the Chinese emperors of the Mongol raids. And like other projects, this project as well had limited resources. That's why the project duration was quite long, a few years, of course. But even then, we saw that the resource management system was in place to divide the workload between soldiers, then citizens, and criminals, of course. Not the best jobs divided, not the best jobs assigned to the criminals, of course, but even then, a resource management system was in place. Then the second one, that's what, is a few years later, the Hoover Dam. That's mentionable because in the Hoover Dam was consulted first time by Henry Gantt. Perhaps one of you know this name, the Gantt chart. The Gantt chart first time was in place to show which actions are requirable and what are the dependencies between these actions. It was crucial because six large companies had to work together, and they have to be managed on an appropriate way. And that's the reason of the Gantt chart was implemented there. More or less between 19 and 1915, the modern program management approaches have been developed and have been implemented.
On the top right, actually, we sum up key characteristics that make not only those projects, but general projects to be projects. And what Sefi just mentioned, this consortium that dealt with the project was one single temporary organizational entity, which is a characteristic for all projects. Now, we jump into actually the Second World War times where another project is to be mentioned. The two projects that Sefi was talking about both had in common that they had a clear target on the one hand side, but also a more or less clear way how to approach this target. So those were projects that were more or less pre-plannable. Now, with the next project, Manhattan Project, that was the project with the target of simply building the atomic bomb. This project not only had the target of building this bomb, but actually also finding a way how to build an atomic bomb. So the way to the target was totally unclear. This made this project the first known large-scale R&D project. And R&D projects have a strong characteristic being very unique and with high uncertainties and high risks. The risks here not being because of we're working with atomic weapons, but because we don't know where the project goes. Now, this project was finished actually only in a bit more than 3 years, where a total of 600,000 employees of the project were managed, $2 billion as a budget, and only 3 years, a bit more than 3 years from start until, unfortunately, the dropping of the bomb. I'll jump now to a very recent Finnish project, which you probably all know. This is the Gotthard-based tunnel, shortly the GBT, which Seifi will talk a bit about it later on. This project was an 18-year project where not only the tunnel was digged itself, but also the technology was brought, of course, in place for the trains to go through and also to have IT connection in there. And this is what I want to point out here. Digging the tunnel was a clear task, not simple at all, but you need to drill the hole there. And this doesn't really change over 18 years. However, putting the technology in there, this is not really a target that you can clearly see in advance because the technology changes a lot over the 18 years. So that is a problem that we are dealing with, and that's why I jumped over a series. Let me mention this project also. This is, many of us know it, but it's actually part of a larger program called the NEAT, the Neue Eisenbahn Alpentransversale program. And the Gotthard Tunnel is only one part of this program. So this brings me to the last characteristic of projects being delimited against other activities, other projects, or also daily operational activities. Now, I jumped over a series of events in the 90s that had similar problems that I was talking about with the technology in the Gotthard Basis Tunnel. Software projects in the 90s were developed or realized using traditional approaches like civil engineering projects, meaning taking requirements, specifying the target, go hacking and developing the product, testing and so on until it's delivered. Back then, in industrial applications, this usually took about minimum of 3 years. Already in the 90s, business changed a lot over 3 years. So the needs that were actually taken at the beginning of the projects weren't met at the end when software was delivered. This led to a crisis that made software and hardware developers come together and start thinking about new approaches of software development, which led to the first publication of the today's most known approach to software development being Scrum. This was published first in 1986. 1986. The date of birth of AWK, actually. So this is when Scrum was first published. But it took until 2001 until 17 thought leaders on this topic came together in Utah in some ski place to ski and eat. Eat is what they say. Probably is more of drinking. And they came up with the what is today known or was back then proclaimed as the Manifesto for Agile Software Development, the Agile Manifesto. This is actually a screenshot that I took this week from the homepage, agilemanifesto.org, and you can't see it, but it's made 2001, shortly after this meeting, and still with the beautiful design from back in the 2000. So what I want to point out is the three basic principles here that this manifesto holds, and this is that we in software development value individual and interactions over processes and tools. We value working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following the strict plan.
So this is the fourth principle then. You said 3, 4.
Thank you, 4, of course. Saying this, it's very important to note that this is valuing the left side more than the right side. This does not mean that we simply build working software without documenting it. No, it's simply more important to have working software than a huge pile of documentation. Now, the third and fourth, thank you, principle address this difficulty that I said with fast changing needs. There's another difficulty that arose in the 90s. That was that the software applications became much more complex. And for this, the requirements weren't even, or people weren't able to specify the requirements and the final target because the products were too complex. And to address this topic of complexity, Sifi, you can go on.
So another important dimension focusing of development software is the complexity dimension. Mary Boone and David Snowden helped us with developing this Canafian. I tried hard to speak out this thing. Canafian framework, which guided us some approaches depending on the complexity of the systems. It has, as you see, 4 quarters, and let's have some explanation on this. Starting with simple systems. So simple systems are understandable very good. So I'm a system as well at the moment. I open this bottle and you know what happened if I drop down this bottle to the ground. Can you imagine it? So I don't have to prove it then. Okay. The second one is more or less a complicated system which contains of a number, more or less a big number of simple systems. Excuse me. For example, building a city. City contains of simple systems, streets, cars, of course, houses, buildings, and well. And it's complicated because it's complicated because these simple systems are to interact to each other. So it's getting a little bit complicated then, but it's still analyzable. So expert can analyze the system and know more or less know good how the reaction of an action within the system will be. On the other hand, we have complex systems. Complex systems are not predictable, more or less are not predictable. Or we need much time and effort to analyze this system. So to develop a complex system, we have to change the approach. We have to leave this analyze approach. We have to start more in an iterative, thanks. Iterative and exploring mode. Because we are not quite sure how the system will act on a certain action. On the fourth, thank you for, on the fourth quarter, there are a chaotic system. We don't want to be within this chaotic system. So every action has to be done to get back on a manageable and even complex or complicated system. For example, task force approach has the goal to get back on management. So in a summary, we can say, on the right side, simple and complicated system can be approached within a traditional classical way. It's even cheaper then because in one iteration we have one-time testing, then one-time rollout, so it's getting cheaper and perhaps faster as well. On the other hand, on the left side, we have to change the approach in a iterative way, agile way to get to the goal, to get to the product we want to develop. So there are other aspects next to the complexity. Michi,
right.
may I
So
hand over to you.
Yes. So since the 2001, then these approaches were developed, all based on a common language, which allows us nowadays to even have a name for this agile approaches, being Agile Project Management. And we dare to point out 4 key characteristics to sum up this of this Agile Project Management. First of all, being the focus on a fast return and on investment, meaning that we deliver early, often, and fast to quickly deliver the value, first of all, to the customer, and second of all, of course, also to us as a developing organization. Second of all, high customer satisfaction, meaning customer centricity. Get in the mindset that you can only be successful if the customer is happy, as simple as that. Third is the continuous inspect and adapt. So the approach is not planning in advance, but in the mindset, acceptance of change is a good thing. Look at change, accept change. It guides you the way to the real needs. And finally, it's a strong focus, on collaboration, meaning that from a leadership level, you have to enable and empower the team members, such that they can decentralize, get to the correct conclusions, that they can show commitment and ownership, meaning that we don't dictate in agile collaborations, but collaborate. Now, let's go on and focus on 2 aspects where these key characteristics show in project management, the first of which being the requirements engineering.
Right. As I said, for a simple and complicated project, as for example, the GPT Gotthard Tunnel is one of it, it's okay if we analyze and specify the objective, the goal in the beginning. Come back to this. So, as I said, it's the fastest and the cheapest way. The goal is relatively clear. The boundaries are clear. And we can set the goal, the classic target, relatively clear on a certain point. We have to, because building a tunnel, it's a good way to know where it starts and where it ends. Okay.
Right. So, as you say, in these examples, you're able to see the target very clearly. What if not? Well, then we deal with Agile Project Management, meaning that we're not able to see what exactly the target should be. The Agile approach is that at the beginning we do frame the scope. One has to do this. One can simply start coding and see where we end. But while framing the scope, one restricts to define the bare minimum of requirements that need to be taken to even get started. And then you start iteratively, code and deliver, and by this, see the reaction, react to the reaction, further specify within these iterations, react to changes, and with this, probe your way to the final target that hopefully, or that has much higher chances to be close to the needs that are actually existent. Now, requirements engineering, let's see now how this affects our daily life, actually, of AWK. Let's have a look at 2 projects that we were involved in from AWK side. So, AWK has the honor to support the federal EJPD, Federal Bureau of Justice and Police, sorry, no, the German word, but not the English, Department for Justice and Police, that's it, within several roles in a project, in a actually program that has the target to renew the platform, software and hardware for acquiring biometric data for Swiss passports, IDs, Ausländerausweise, travel documents, visa. This program is organized in different projects, one of which being the software development of the central and decentral servers, the decentral servers that run at the locations all over the world where you have these hardware scanners. We're talking about facial biometric images and fingerprints. So the software part of this program, so the software project, is run in an agile way, following Scrum. What does this mean for the requirements? Well, one started actually before the actual project started by designing the architecture based on only 8 architectural goals that were defined by the overall program. Designed this architecture, which was the base for all the software application in the following program. Then once budget was approved, one started develop. One quickly built a running prototype system, what we call dummy system, for the other applications that interact with this backbone software. To be able to test their software, but also to be able to go to key users and probe the functionality, the usability, and so on. So we were able to quickly start and probe with this our way to what was really needed. How is this in the Gotthard Tunnel?
Yes. Let's start with a few figures first. I had to read it from the paper. The GBT runs 57 kilometers of railway, as you perhaps know, but has 151 kilometers of tunnels and passages in it. The construction started in 1999, and the opening was 2060. And the total amount of the project has been 12.2 billion Swiss francs. AWK had the honor to engineer the technical communication within the project. That's why you can use your handy, and it still works, even into the tunnel as well, and was involved as well in the railway communication system and the railway control system. First of all, as I said, it's advisable to know where it starts, where it ends, and where it's going to. Because the way, okay, we have to build a tunnel, let's start, I think that wouldn't be appropriate in this situation. So there was a lot of specification work done. They took us about just for the communication system about 10 years of specification and engineering the system, also the communication system. Nevertheless, 18 years ago, for example, 18 years ago, around 2000, Ericsson released the first smartphone, R380S. It has an astonishing amount of 99 entries in the telephone book. Also, it was quite sophisticated, and we based on the 2G standard, 2G communication standard. As you see, over the 18 years, the technical communication changed a lot. So the difficulty was, even if you have to specify everything, to have the specification as flexible and as changeable as possible. On the other way, it had to be clear what has to be done. Furthermore, a lot of requirements were added to the technical communication project, and it ends in 2007 by the increase of 20% of cost for the whole tunnel. So the planned cost at this time were 12 billion, and we reached 12.2 billion, quite near. And if you compare these two projects, we see, okay, obviously more construction-oriented projects or technical projects can be approached with more traditional way, and obviously, I don't know why, more software development project, they have to change on a more iteratively, now I got the word, iteratively way. So, why is that so? Let's look to this picture on the left side. It's very feasible and summarize the agile collaboration very, very good. We are, for software development project, we have to build on a team, on a collaborating team. Perhaps, as you know, for yourself, it's not very, sympathetic to command an order, to have to command an order strategy in a collaboration. So obviously, we have to build on every person and have to give them as much freedom as they want. As much freedom as they want, as we can give them to guide them to a specific way. He said that it's good. He said, okay, we have to go over the river, figure out how. And on the other side, we have to give the clear vision, also set the frame, because time and cost are resources that we need to
allocate.
Pardon?
Allocate.
To allocate, of course, and there are resources. There are resources. There are resources which have to prepare. So we have to frame the collaboration. Also, the leadership has to change. Not command and order is the way. Serve and protect the team. And these are 4 agile collaboration principles which worked very well until now.
Well, they do work very well if you actually obey to them. So let's see again in the project how this works. And collaboration, difficult topic in this ESSP program, I have to tell you. So I said they were running following Scrum. Scrum means that we deliver within sprints. That's period of times of usually 2 weeks. And there's 3 very important roles. There's a product owner in a development team that is responsible for the content, so to say, and the prioritization. There's a Scrum Master who solely looks at the functioning of the team. He's responsible for all the events and that the team can actually work and deliver. And of course, the developer. The developer has to commit to items that he pulls for himself and says, okay, team, this is my job. I will do this within 2 weeks. Now, how did this work here? As I said, they did work after Scrum officially. They did deliver. However, if I recall, or if I think about it, it was actually the product owner that ran all the events, and no Scrum Master was there. Actually, what they delivered was what the product owner told them to deliver. So there was no real commitment from the developing side. Why didn't anyone tell the product owner not to simply dictate and tell the team what to do? Well, there was no Scrum Master. He was the Scrum Master himself. So the lack of splitting roles was a big problem here. They did deliver. frequently, continuously, all 2 weeks, but they didn't deliver what they committed on for each sprint. So there wasn't actually sprint goals. They simply delivered whatever was available. This means this is not really an iterative Scrum approach. This is more a continuous chaotic delivery. So there was a big potential for improvements there.
Unfortunately, we have some negative experience in the traditional way as well. 2 examples. The different companies involved in this project focus very much on their subsystem. And they build it as good as possible, but during the integration of these subsystems, we had big troubles in it. So we needed much amount of time and effort to interact, to get the interaction between these systems quite well. On the other hand, furthermore, we struggle, let's say, with faith in specification. So the companies did their subsystem according to the specification as much as possible. But they didn't think about over their own boundaries. The effect was we need more or less 1 year to test the whole system. So the Gotthard Tunnel was prepared, was built in 2015, and we need more or less 1 year to 2060 to ensure the functionality, the whole functionality, to ensure the communication between these systems.
So we talked about 2 aspects now, where you see a bit of a difference of the approach of the traditional and the agile approach. There is an entire list, and this is a list that doesn't claim to be the full view of aspects where you can compare traditional to agile approach. Just to mention 2 or 3 of them, we pointed out in IT project with an agile approach, the difficulty is that we're dealing with highly complex systems usually, that we can't acquire the exact requirements at the beginning. So we approach them with an iterative and adaptive way of planning and delivering small pieces.
Yes, in traditional project management, we raise requirements at the beginning and plan linearly in advance, because that's possible, because the systems are more or less simple or complicated.
For our approach in IT to work, we need to actually work closely with the customer and listen to him to meet his actual needs, rather than a document like a contract stating what has to be delivered.
Yes, in traditional project, perhaps we have to specify the goal in the beginning. As I said, tunnel, entrance, exit has to be defined in advance.
And finally, in the IT approach, it means that we deliver fast and, as I said, in small pieces to slowly probe our way to the final target.
And of course, the Gotthard Tunnel cannot be developed iteratively, because it works or it doesn't work, period. So we have to deliver everything at the end with a big bang.
I think we'll only show this. There is, of course, success factors that need to be met to be able to decide if you will be successful or not in Agile Project Management. Now, let's get back to the initial question. Is now IT enabling a revolution, or is it simply missing its chances? Well, we pointed out that IT actually bundled a lot of different approaches to one common language. It did push these approaches even into the traditional project management. It's a fact that today over 80% of IT projects are or do include agile methods, so are either run totally on an agile way or include agile methods, and also entire organizations that deliver projects, not only IT projects, are set up based on agile principles. On the other hand, it is a fact that most organizations still lack end-to-end agile mindset. The agile mindset we pointed out in a few slides there. This means also that most teams lack the necessary empowerment to be able to run agile. Many agile teams don't, even if they follow officially, like in my case or in our case, officially agile methods like Scrum, they don't really follow and obey to the Scrum rules or agile rules and processes. And finally, many key employees still come from the old world or also work in the old world, in the traditional world, and they lack...
Thanks a lot, Michi. I love you too.
They lack the agile maturity and mindset. So it brings us to the conclusion that, well, both, actually. It already did enable a revolution because it had the needs and it pushed everything that was on the left side, even into traditional project management. But at the same time, it is still missing many of its chances. With this, we hope to have given a short answer to this question and are open for your questions. Yes.
In the beginning, you showed us the manifesto of Agile, which is a bit old. If you could rewrite it, this manifesto for Agile, what would what you put in there now?
Oh, that's
a nice one.
for an agilist, this is like playing God.
I would change the over. I would change the over to a big over. So functionality over.
Documentation.
No, not documentation. Sorry, over the comprehensive documentation. It's not as we said. Functionality, no documentation, and that is very misleading. I would change this, but only this. Okay.
Well, I'm just curious to know what you think about the fact that the agile software development approach was originally stems from the Silicon Valley. So you have a bunch of young people who are really self-motivated, and we're not trying just to imprint that into every single company, no matter what people are working on the project. So, as you pointed out, right, you're limited by the people who are actually doing the work. So it might just be a natural consequence that this approach is, or IT kind of is failing in some aspect, because every developer just grabs the work, right, and commits to doing it within 2 weeks. You also have to include like employees who probably don't go for the extra mile, unless you say, okay, I'm just going to clean up my team, I throw out all the standard employees, I raise the bar, and I only get the exceptional ones.
It's a very good point. Before I answer the greatest part of the question, it's actually not coming from or not invented by Silicon Valley and IT, but it's actually approaches that they gathered, and mainly it's actually from hardware world, from Asia, from Japan. All these thoughts, customer centricity, value driven, and so on. But your point is a very good point. Don't forget that a developer can be developed. So it's true, not everyone, you can't come in a team and say, now we're agile and you work agile. You need to work on these people as well and bring this mindset to them. And it's true, not everyone will reach the same, what we call maturity level of this agile mindset. Our approach is to work with and on the people, to collaborate. By the way, the Scrum Master is actually someone who not only looks at the process, you need to do it this and that, but also coaches. He is a coach. He coaches the team also on the topic of this mindset.
Actually, because I never understood what is a Scrum Master doing.
A Scrum Master is a coach, an enabler.
Yeah.
Scrum Master enables the team to perform. Scrum Master coaches the team to perform.
It's just so rare that there is a good Scrum Master.
Okay.
Come to AWK.
Your mind will be set there.
On that point, I have to cut you off. Sorry about that. But we are already at the end. Thank you very much, Josef and Michael, for the wonderful presentation. Another applause, please.
Thank you for listening. Thanks.